All right. Sorry about that, everybody. Although ironically, you guys got me out of a very awkward situation. I'm like, oh, I can't do that. I gotta go teach. All right. All right, everybody. So sorry about that. A little bit late, but welcome. Good afternoon. How's everyone doing today? Good, good. All right. So learning objectives. You're just gonna do more rate of return. Okay. Okay. So announcement. So like I mentioned on Tuesday, homework 3 is posted online. And homework 3 is kind of the last of the topics and the last of the material that I'm gonna expect you guys to know for the exam. Okay, so definitely that's important. And that's going to be due on Tuesday by 11:59 p.m. The midterm exam is going to be next Thursday. So that's a week from today. And remember, the midterm exam is going to be an in-person exam, and so everyone, you have to show up in class. There's no plans to offer it virtually. But if for some reason you can't make that exam date, if you can't come to campus on that day, please let me know as soon as possible. Then we can arrange a makeup at some point. Okay. But at this time, the only plans to have the exam in person here in the classroom next Thursday. Okay. One thing I forgot to mention, just because it's been a while and it kind of slipped my mind. On Monday, I plan on recording a kind of like a review video for you guys for the exam. Okay. Okay. And so what I usually do is that, the study guide for the exam went out on Tuesday of this week. Okay. And so you can find that on the Canvas site. And so if you click on week 5 of the Canvas site, you'll see the study guide, which has all the topics for the upcoming exam. What I'll do is that when I get back to my office after the class today, I'm going to put out a poll on Canvas where you can vote on the topics you feel most uncomfortable with so far in the class. Okay? We haven't done that much so far, so all we've done is just a basic introduction. We've done cash flow diagrams, cash flow conversions. We've done present worth analysis and annual cash flow. And so I'll have you guys vote on the topic that you feel most uncomfortable with. And then usually in the video, I have time to cover, either the top 1 or top 2 topics that people want to see most. Okay. All right, question. So do I post step-by-step solutions of the homework? I do. And so I usually post the solutions right after I grade the homeworks. And so homework 1 solutions should be online. And homework 2 solutions, I'm hoping will be done by today. I know I said I would finish it yesterday, but some stuff came up yesterday, so I wasn't able to do it. But I should be able to grade homework 2s today. And then the solutions for homework 2 will be up on as soon as I finish grading those. Okay. Yep. And so usually I post the solutions in the week that I grade them, which can be hard to find. And so I think the easiest way to find solutions is to go to files and then solutions. And so that's where I put the files. And so that's usually the best way to find. Okay. All right, and so remember for the exam, it's going to take place in lecture, so the time limit is 75 minutes. You can bring a pencil, you can bring a calculator, you can bring a single sheet of notes, and so that's one 8.5 by 11 sheet. You can write anything you want on it, front and back. You can type it, you can write it, whatever you want. The only requirement I have for the cheat sheet is that you be able to read it. And so no extra props, no magnifying glasses, no weird. I know people do a weird thing with like blue red ink, and so none of that stuff. Just has to be just plain writing, and you should be able to read it. You can even do this if you want, do the whole like Henjong thing, but just make sure you can read your cheat sheet. I say that because anytime there's a weird statement like that, you always have to ask, was there a weird incident that caused this statement? And yes, there was a weird incident that caused this statement. Okay. But that's all I'll say. All right, any questions on any of this before we continue with rate of return today? Okay. All right, and so all right, so let's go ahead and continue. I'll find where we left off in the notes. Okay. Okay. And so we're continuing with rate of return. So, rate of return is a I think a very unique type of analysis compared to what we've done so far. But I think that's what makes it really interesting as well. And so kind of in a nutshell, what we're looking for rate of return is we're looking at a situation where all the cash flows are given to us, and we need to find the interest rate that kind of balances all those cash flows. Okay. Okay. All right, and so remember the way that we do this is we set up some kind of equivalency statement for the problem at hand. Okay. And so that equivalency equation can take a lot of forms. And so I think traditionally and kind of most easily people compute the net present worth of a particular situation. Okay. And so the way we did this is we took all the cash flows associated with the project or with an application. We converted everything to present worth, and then we set it all equal to 0. Okay. That's just one example. And so you can do the same thing with annual cash flow. So you can convert everything to a uniform series, or you can convert everything to a future sum. Or if you're a madman, you can also convert everything to an arithmetic gradient if you really want. But the point is to just kind of convert everything to the same form of cash flow and then set it equal to 0. Okay. And then from here, what you need to do, and there's several ways to do this. Once you set this up, you need to solve for the interest rate I that will make this statement true. Okay. And remember, last time we talked about 2 different ways that we can do this. And so one way is you can use formulas for the cash flow conversions. Okay. So remember, one of the first things we learned in this class is that when you're converting between different cash flow types, there are equations or formulas that you can use to do that. And so you can set up this equivalency equation with those formulas, and they do have the interest rate I in those equations. And then all you have to do is just solve those equations for I. But typically, because these equations involve, exponents of very high numbers, they're usually very difficult to solve by hand. So the only practical way you can really solve these, for any kind of, problem that has any kind of complexity, is to use some kind of graphing software. Right, and so we talked about that briefly last time. And so if you're savvy with MATLAB, then that's one way that you can do it. Okay. The other way that you can do it is you can use the compound interest tables, right? And so that was the last example we did before the end of class. The only downside to this is that this method here involves quite a lot of guess and check. Okay. And then ultimately, it's going to require some kind of interpolation. Okay. Because the compound interest tables, even though they're great tools, we only really have the conversion factors for certain interest rates. And so we only have them usually for the whole numbers like 3%, 4%, 5%. And usually the true rate of return is somewhere in between two of the tables. And so you're going to have to interpolate in order to get the final solution. Okay. All right. And so that's kind of the the idea in a nutshell. But if you remember, when we started on Tuesday, I said that the whole idea behind rate of return is that it's even though it's quite different, you can still use it for the same purposes as present worth or annual cash flow. Okay? In other words, we can use rate of return to perform economic comparisons. Okay. Right, but in order to do that, we have to kind of set up the problem a little bit differently. Okay? And so we have to do something called incremental rate of return. Okay. Okay. So let's do a simple example here just to kind of illustrate this. Okay. Okay. So this example is going to be pretty simple, and so we're not going to need any of the compound interest tables, but I just want to kind of illustrate this idea of incremental rate of return. Okay. And so let's say that you're considering investing some of your money between two of these alternatives. All right, so we'll call them alternative 1 and alternative 2. And just for the sake of simplicity, this will be a 1-year investment. And so you're going to deposit. And so for both these cases, you're going to deposit some amount of money into an account today, and then 1 year later, you're going to reap the benefits. Okay. And so for alternative 1 says that if you invest $1,000, 1 year from now, you're going to get $1,500. Okay. For alternative 2, you're going to invest $2,000, and you're going to get $2,800. Okay. Okay. In addition to this, we also have some information on the general market. Okay. And so we're going to introduce some new terminology here. And so whenever you're doing these incremental rate of return problems, you're also going to be given what's called a minimum attractive rate of return. Okay. The minimum attractive rate of return, it's a kind of a mouthful, so we shorten it to MARR. Okay. And what it represents is it basically represents, the minimum rate of return that we would want in order to make this investment worth it. Okay. Okay. Another way that we can interpret MARR, and I personally like this one a lot better just because it's, it makes interpreting problems a lot better. You can think of the MARR as kind of the general market rate. Okay. And so, outside of these two alternatives here, there's also, other opportunities in the market for you to invest your money, right? And so this MARR is that rate. Okay. Okay. And so for this particular problem, we're going to have an MARR of 10%. Okay. And so that means that any money that we don't invest in either alternative 1 or alternative 2, we're going to get a 10% rate of return on. So that's basically all it is. Okay. All right. And so based on the information that we have here, what we want to do is we want to determine which alternative do we want to go for. Okay. All right. Any questions so far on any of this? Okay. All right. So before we begin, I do want to make one kind of important distinction. Because I think the results of this example, I think, might be a little bit counterintuitive, when you first look at it. Just by the fact that we're considering these two alternatives, that means that we have at least $2,000 to spend. And so what we can say is that our budget here is $2,000. Okay? No matter if we pick alternative 1 or alternative 2. Okay. And so no matter what, we want to spend $2,000. But, when you have alternatives like this, and so you look at this and you say, maybe we should do alternative 1 twice. And so if we do alternative 1 twice, then that, that's going to be better than alternative 2. But usually the way that these opportunities arise is that you don't really have the chance to double dip. And so, what the decision we're trying to make is, what's the best place for us to spend this $2,000? Okay. And so if we go with alternative 1, what this means is that we're going to take $1,000 and then we're going to invest it in alternative 1, and that's going to become $1,500. Okay. But for the other $1,000, we're going to invest this in the MARR, the general market rate. Okay. And the general market rate is 10%. And so if we get a 10% rate of return on that, then that second $1,000, we're going to get $1,100 from that. Okay. The alternative to this is we invest everything into alternative 2. Okay, so we put $2,000 into it. And then just based on the numbers we're given, this tells us that we get $2,800. Okay. And so, I didn't intend for this, but this kind of spoiled the example. And so, in this case, it's actually going to be better for us to do alternative 2, because if we do alternative 1 and we split up that $1,000, we're only going to get $2,600 in total. But if we invest all of it in alternative 2, we get $2,800. Okay. And so you kind of already know the answer, but just kind of pretend to be surprised when you see the answer. Okay. All right. And so now let's kind of approach this problem from a rate of return perspective. Okay. Okay. And so let's do alternative 1. Okay. We technically don't need any fancy formulas for this, but let's just for the sake of kind of nailing down this process, let's set up our net present worth equation. Okay. And so for net present worth, we're going to convert everything to a present sum. And so first we have the initial cost for alternative 1, which is $1,000. And so we have a minus 1,000 plus 1,500, but that 1,500 is taking place 1 year in the future. And so the conversion we're going to do is a P over F, I, and 1. Okay. And then we're going to set that equal to 0. Okay. All right. And so since this is a simple case, we can go ahead and just plug in the formula for that. Okay. And so we have a minus 1,000 plus 1,500 times 1 over 1 plus I. Okay. Right, and so where I got that 1 over 1 plus I, that's just our compound interest formula. Okay. All right, and so now we can solve this equation for I, and so let's go ahead and multiply both sides by 1 plus I. And so we have a minus 1,000 times 1 plus I plus 1,500 0. Okay. Let's go ahead and move the 1,000 over and the 1,500 over. Let's move the I to the other side. And so we have a 500 is equal to 1,000 I. Okay. Right, because on the left-hand side, we have a minus 1,000 plus 1,500, and so that's just 500. And on the right-hand side, we moved that 1,000 I over to their side. So that's how we got that. And so we simply just divide both sides by 1,000, and we get I is equal to 0.5, which is equal to 50%. Okay. So that just kind of confirms what we can kind of see just visually, right? And so, pretty straightforward case. We put some money in, we get some out, and then the rate of return is just basically the ratio of how much money that we got out to how much money we put in. Okay, so let's do the same thing for alternative 2. Right, so we do the same thing. So we're going to compute the net present worth, set it equal to 0. But for alternative 2, we have a minus 2,000 plus 2,800 P over F I1. Okay. And then we're just going to repeat the calculation. And so I'm just going to go a little bit fast here. Okay. And so if we repeat the same thing for alternative 2, we get a rate of return of 40%. Okay. All right. And so, here are our answers. And so, based on the rate of return analysis, it looks like alternative 1 is the better one to do because we get a higher rate of return on alternative 1. But that's inconsistent with kind of I would call this, kind of a back of the envelope kind of calculation here. Okay. And so how do we reconcile these 2 points? And so how do we reconcile the fact that, rate of return is telling us one thing, but our back of the envelope calculation is telling us the other? Okay. Well, and that's the secret behind incremental analysis. Okay. But before I jump into that, are there any questions on how we computed any of this? Yeah.
If the like time difference was, I think it wasn't a 1, did that change for the equation?
Yes, yeah. And so if you remember, our compound interest formula was F is equal to P times 1 plus I to the N. Right. So I just moved that to the bottom there. And so if the time period wasn't 1, and so let's say it's 3 years, this would be a cubed right here. Yeah. And it's amazing, you add 1 exponent, it becomes a bajillion times more difficult to solve. So, I picked this one just because it's easy to solve by hand. Okay. Any other questions on this? Okay. All right. And so how do we reconcile these 2 points? Well, if you go back to how I wrote this example here, I've left a 3rd column there, and that wasn't a mistake. And so I did that on purpose. Okay. And so whenever you do incremental analysis, the incremental comes from the fact that we're going to take the difference in between two things. Okay. And so let me make a 3rd column here, and this 3rd column is going to be the difference between alternative 2 and alternative 1. Okay. Okay. And so we're just going to subtract across the row. And so for the initial cost, we're going to do a minus 2,000 minus a negative 1,000, and so this is going to be a minus $1,000. Okay. And then for the second row, we're just going to subtract across 2. So we're going to do 2,800 minus 1,500. And so what we get from this is 1,300. Okay. So let's compute the rate of return, but let's do it for this last column now. Okay. And so we're going to take the rate of return of the difference between the 2 alternatives. Okay. And so this will be the rate of return of alt 2 minus alt 1. Okay. All right, so just like the other 2 cases, we're going to set up the net present worth equation, and so we're going to keep the net present worth set it equal to 0. Okay, and then from this 3rd column, you can see we have an initial cost of minus 1,000. Okay. And then we have a benefit of 1,300 occurring 1 year into the future, and so that's going to be P over F. I1. Okay. So I'm not going to repeat the whole thing. It's just kind of based on the numbers here, we can see that the difference here, the rate of return for the difference, alt 2 minus alt 1, is 30%. Okay. Okay. All right, so you're probably thinking, now it's worse, right? And so, we had 50% with alternative 1, 40% with alternative 2. We take this difference and we get an even lower rate of return, right? But here's the kicker. And so, taking this difference here is clutch, because what this difference is you can think of this difference as, the difference between the cash flows if you pick alternative 2 versus alternative 1. Okay. Okay. And so what this is saying, that if we pick alternative 2 versus alternative 1, then the difference that we're making, the difference in the money that we're making is, the rate of return on that is 30%. Okay. Remember, in this problem, we're also given the MARR. Okay. And so the MARR here is 10%. Right. Right. So when I was defining the MARR as the minimum attractive rate of return, what I was really saying is that the difference, the rate of return of the difference between these two should be at least 10% in order for us to select, you know, the more expensive alternative. Okay. And so, you know, to kind of sum it up, here's kind of what you do. And so this rate of return here, the one that we obtain, you know, from the difference, this is known as the incremental rate of return. And so usually we give this the symbol delta IRR. Okay. And then in order to make a decision on which option you should choose, you need to compare the delta IRR to the MARR. So lots of acronyms, but you know, the alternative is saying the full name, which is really long. Okay. And so let's kind of summarize this in the table. And so we basically have two cases. And so if the delta IRR is greater than the MARR, okay, I don't know why I made it as a table. We don't need to be a table. So that, okay. And so if the delta IRR, if that's greater than the MARR, then what you want to do is you want to choose the higher cost option. Okay. And then the other case, if the delta IRR is less than, and we'll say less than or equal to, and it doesn't really matter, but very rarely do you get a case where you get equal interest rates. And so if it's less than or equal to the MAR, then you're going to choose the lower cost option. Okay. And the and part is implied, and so you know you don't have to say it in the problem, but the implication is that if you invest part of your budget in the lower cost option, then you're going to take the rest of your budget and invest it at the MAR. Okay. Okay. And so this is the basics on how you do incremental rate of analysis. Okay. And so if you're put in a position where you're going to use rate of return to make a selection, then this is basically how you do it. And so first thing you're going to do is you're going to take the difference between the two options. You're going to take the higher cost option minus the lower cost one, compute the incremental rate of return, IRR, and then compare that to the MARR, and then you know use that to determine what you should do. Okay. All right. Any questions on any of this? All right. So I'm going to do, you know, a couple more examples just so that you can see how it's done. But I did want to mention that, you know, for this particular example, just for kind of educational purposes, we computed the rate of return of each option individually. When you're doing incremental rate of return, you don't have to do that, and so you can just jump straight to the difference. Okay? Okay. So let's do another example to kind of put this into place, and let's do one that's a little bit more realistic, because you know, that last one was like a fictional investment. Because hey man, if I can get a 50% rate of return on something, man, I'm putting all my money. But you know, that's not realistic. Okay, so let's do another example. All right. And so a very common dilemma that engineering companies face is that, you know, they need some equipment to accomplish some kind of project or do some kind of job. And there's a decision to be made whether the company should rent the equipment or if they should just buy it straight up. And you can use incremental rate of return analysis to determine, you know, what would be best for the company. Okay. All right. So for this particular example, this engineering company is needs some additional equipment to bolster production. Okay. And they have the option to either lease it or to buy it. Okay. All right, and so the terms of the lease are actually kind of a month by month term. And so, you know, if the company were planning to lease it, they would have to pay a fee each month. Okay. And so here's how kind of the payment structure breaks down. And so first column here, we're gonna have the month. Okay. Here we're gonna list the cost for leasing. Here we're gonna list the cost for buying. Okay. And this is going to be over a 24-month period. And so this is going to be for 2 years. And so just to simplify this, so I don't have to write, you know, 24 entries. You know, we're going to say the leasing costs are going to be the same in months 1 through 23. Okay. And then in the 24th month, you know, we might have something different. Okay. All right. And so for the lease, you know, the way this leasing term works, just like most leasing terms, is that you pay at the beginning of the month to use it for the upcoming. Okay. And so to lease it, you know, we're going to have an initial cost, $2,500. Okay. And so that's to use it for the first month. And then in each of the months 1 through 23, we're going to pay an additional $2,500 to use that equipment for that month. Okay. Right. And so we have, you know, the $2,500 cost for basically 24 months straight, counting the 0th month. Okay. But then in the 24th month, you know, we're not going to pay anything because, you know, we kind of prepaid for that month kind of upfront. Okay. The alternative is just to straight up buy that equipment. And so buying the equipment will cost $40,000 upfront. Okay, so much larger. But, you know, there are going to be no additional costs associated with this. Okay. And so in months 1 through 23, we're going to have $0 because we bought the equipment. We own it. Okay. And then what we'll say is that at the end of the 24th month, since we're done using that equipment, we're going to salvage that. We're going to salvage the parts. So we're going to get some of the money back just by selling it. And so we're going to say that we get $6,000 back by selling the equipment in month 20. Okay. Okay. And so what we want to do is we want to use incremental rate of return analysis to determine whether we should buy or we should lease. Okay. Okay. Oh, I need to give you an MARR. And so let's assume that the MARR is 6%. Okay. And so that's going to be the number to beat. Okay. And so just like the previous example, we're going to take the difference between these two options. Okay? But remember that the order in which you take the difference is key. And so whenever we do incremental rate of return analysis, we're going to do the higher cost option versus the lower cost. And that's only strictly from the initial cost. And so we're going to see which one has the higher initial cost, and we're going to subtract the other one, which has the lower initial cost. Okay. And so for this case, it's fairly obvious. And so, the one with the higher initial cost is going to be buying, and then the one that's lower is going to be leasing. So we're going to take the difference between buying and leasing. Okay. All right, so let's go ahead and perform that difference. And so we take minus 40,000 minus a negative 2,500. So that's basically minus 40,000 plus 2,500. And we get 37,500. Okay. Minus, sorry. Okay, and so now we have the difference between in months 1 through 23, and so we have a 0. Okay, so we buy is 0, and we minus a negative 2,500, and so that gives us a positive 2,500. Okay. And then finally, we have the last row, which is the salvage cost. And so that's going to be 6,000 for the buy column minus 0 for the lease column. And so that's going to be positive 6,000. Okay. So there we go. And so now let's go ahead and find the rate of return of that column. And just like we've always been doing, let's go ahead and compute the net present worth of that last column. Okay. All right, so let's start with the initial cost of the increment. And so we have a minus 37,500. Okay. Okay. Then we have a positive cash flow of 2,500, and that is for months 1 through 23, and that's a recurring cost. And so that's going to be a uniform series for 23 months. And so we have a P over A, okay? Because we're taking a uniform series, we're converting it to a present sum, so that's P over A. We don't know the interest rate, and so we'll leave it as I. And this is occurring for 23 months. And then finally, we have the salvage value. So the salvage value is $6,000. Okay. And that is a future sum. And so to convert that, we're going to have P over F, I, and 24. Okay. Right, and so that is our net present worth equation. Okay. All right, and so unlike our previous example, this one's going to be a lot more difficult to do with the equations. And so let's use the compound interest tables and let's start plugging stuff in. Okay. All right, and so remember the way that the compound interest table method works is that you just need to kind of start somewhere and then start computing the present words, okay? And so let's start at 3%. And so if we compute the present worth when I is equal to 3%, then what we have is minus 37,500 plus 2,500. We look up the P over A value for n is equal to 23 and I is equal to 3%. And if you look that up in the table, this is 0.4919. Or excuse me, sorry. I'm reading these out of order. So this should be 16.444. Sorry about that. In my notes, I have the 6,000 the 2,500 switch, and I just didn't notice it. All right, and then we have the 6,000, and then this 6,000 is going to be multiplied by 0.491. Okay. All right, and so we do the arithmetic, and what we get is $6,561.44. Okay. Okay. So we're not quite there. Remember, we're looking for the interest rate that's going to make this present worth equation 0. And so, we're still quite a bit off. And so since we ended up with a fairly positive present worth, let's go up and the interest rate, and then you'll see that it's actually going to come down a bit. Okay. And so let's do the present worth for I is equal to 4%. Okay. And so let's go ahead and repeat this. Okay, so we have minus 37,500 plus 2,500. And the P over A factor for this case is 14.857. Plus 6,000 and 0.3901. And so you'll notice that the conversion factor is getting smaller. So we go from 16.444 to 14.857. Okay. And then we go from 0.4919 to 0.3901. So this should bring us closer to 0, although it might not get us there exactly. Okay. And so we perform the arithmetic again. And so we punch it in the calculator, we get 1983.10 cents. Okay. Okay, so let's go up one more. And so let's go from 4% to 5% and see if we cross 0 in this case. Okay, so we have minus 37,500 plus 2,500, 13.489 plus 6,000 times 0.310. Okay. And so we punch this in and we get minus 1916.9. Okay. Okay. So that's good. And so, in going from 4% to 5%, you can see we went from positive to negative. And so somewhere in between 4 and 5%, we hit the 0 mark. Okay. And so since okay. And so just like we did with the example on Tuesday, let's go ahead and interpolate and find the and find the true rate of return. Right? All right, and so if we interpolate, then what we're going to get is the delta IRR. Okay. And so interpolation formula, we're going to go I low. And so I low in this case is 4% plus the difference between them. And so it's 5 minus 4. Okay. And we take the difference of the present worths. And so we do 0 minus 1983, 10 divided by minus 1916.9 minus 1983.10. Okay. All right, so all I did was, I think at the end of lecture on Tuesday, we had our equation for the interpolation, and so I just kind of plugged in for those. Right? And remember to be careful here, because when you're plugging into this parentheses here, if you look in the formula, you have things like PW low and PW high, right? But remember, this does not refer to whichever present worth is lower or higher. These are the present worths that are associated with the lower interest rate and the present worth associated with the higher interest rate. Okay, so remember, just to be careful about that, because I see that kind of messed up a lot. Okay? All right, and so if we plug all this in, we get 4.51%. Okay. And so what this tells us is that the incremental rate of return, and so we take the difference between buying and leasing, that's a 4.51% interest rate. Okay. And so we're not quite done yet. And so remember, what we have to do now is we compare this to the MARR. Okay. And so since the MARR here is 6%, okay, what we see here is that the delta IRR is less than the MAR, right? Okay, because 4.51% is less than 6%. Okay. And so if the delta IRR is less than the MARR, what does this tell us? And so this tells us that the better option would be to go with the lower cost option. Okay. And so the lower cost option in this case would be leasing it, right? And so you lease, the machine. You end up with a big pile of money because you have the extra $40,000, or you had a budget of $40,000. Okay. And then whatever you have left over, you invest in the market at 6%. Okay. But for just this specific problem, you can tell your engineering manager, you can tell your company boss or whatever that the better option is to lease it. Okay. Any questions on this example here? Okay. All right. One other kind of small point of nuance here. And so, we computed this delta IRR, but I think, with this example here, we can get kind of a more concrete understanding of what this kind of represents. Okay. And I bring up this example of buying and leasing kind of for multiple reasons too. Because generally speaking, even though buying equipment often has a higher initial cost, I mean, it always has a higher initial cost, right? The reason people consider buying equipment is that, if you buy a piece of equipment, over time, it's going to be less costly, right? And so, if you buy a piece of equipment versus you lease it out from somewhere, it's going to be less cost for you in the long run. Okay. And so what this represents here, what this 4.51% here is, this represents the rate of return of basically choosing to buy over leasing. Okay. Okay. Right, and so that represents, financially over time, how much better it is to buy rather than lease. But whenever you're making comparison like this, you also have to take into account, what the market's doing at the time too. And so that's why we include the MARR, and that's why, we compare that to the delta IRR, tell us what to do. Okay. And so even though, the more expensive option most of the time in most practical cases is going to result in more money over the long run, just kind of in a vacuum. But a lot of economic decisions are not just made in that vacuum. And so you have to kind of consider what's going on outside as well. And so that's what the MARR is. Okay. Okay. And so I have one more example. And so we're going to do one more example today, and then we will call it for today. So we have 15 more minutes. Okay. And so let's consider a case where we have two machines that are considered for purchase. Okay. And I was not creative with these, and so I called it machine X and machine Y. Yeah. All right. Okay, so I picked this example. So this will be an example for a case when you have different useful lives as well. Okay. All right. So both options are going to have an initial cost. Okay. Both machines are going to give you a net profit or a net benefit each month. Okay. And so we're going to model that as a uniform series of a benefit. Okay. Both options are going to have a salvage value. Okay. And finally, we'll consider the useful life of both machines. Okay. Okay. And so we'll say the initial cost for machine X is going to be $200, whereas the initial cost for machine Y is going to be $700. The uniform benefit for machine X we'll say is $95, where machine Y will earn you a bit more money each month at $120. Okay. For salvage values, we'll say machine X has a salvage value of 50, and whereas machine Y will have a salvage value of 150. And so here's where this one's going to be different. And so for machine X, we'll say that's going to last about half a year. And so we'll say that'll last 6 months. But for machine Y, that's going to last 12 months. So it's going to last you for a whole year. Okay. And so if we assume an MARR of 10%, okay, let's determine, or let's choose, which machine should the company buy. Okay. And so of course, we're going to use incremental rate of return. And so, in order to do that, we have to take the difference between the two options. Okay. And so we're going to take the option that's more expensive minus the option that's less expensive. And so in this case, that's going to be machine Y minus machine X, because machine Y has higher initial cost. Okay, so machine Y minus machine X. And let's go ahead and take the difference. Okay, we have a minus $500, okay, because that's minus 700 minus a negative 200. Okay. And so that gives us minus 500. For the uniform benefit, that's going to give us a difference of $25. Okay. For the salvage value, we have 150 minus 50, which gives us 100. Okay. And then finally for the useful life. And so, for the useful life for this one, we're going to apply the same rules that we did for present worth analysis, where we're going to take the least common multiple of their product lives. Okay. And so in this case, we have a product life of 6, product life of 12. And so the least common multiple between them is going to be 12 months. Okay. All right, so that's the difference. And so, when you're doing incremental rate of return analysis for options with differing time periods, you have to do a the time period that you analyze it for is going to be 12 months. Okay. And so let's go ahead and set this up. And so just like we've done before, we're going to compute the net present worth. And set it equal to 0. Okay. And we're going to do that for the increment. And so we have NPW is equal to. Okay, first, we have a minus 500 because that is the initial cost. And since that $500 is occurring in the present day because it's an initial cost, we don't have to do any conversions on that. Okay. Next, we have the uniform benefit of $25. And so that's going to be a uniform series. And so to convert that to a present sum, we do a P over A factor with an interest rate of I. And the time period here is 12 months. And then finally, we have the difference in salvage values. Okay. And so the difference in salvage values are going to be a P over F factor. Okay. And we're going to salvage at the end of month 12. Okay. And so it's going to be P over F, I, and 12. Okay. Okay. Right. And so that's the net present worth equation that we get just straight off the difference column. But we're not quite done yet, right? And so we have one additional cost that we have to consider because of the fact that we have differing product lives here. Okay? And so compared to machine Y, machine X only lasts for half the time. And so whenever we do a least common multiple approach, remember the assumption that we make is that once the first, once a product kind of reaches its end of life, we buy a replacement at the same cost as the original. Okay. And so the one more entry that we're going to add is that for machine X, we have to buy a replacement in month 6. Okay. And so there's actually one more row to the table that's kind of implied, but we can write it in table form just for consistency. Okay. Oops. Okay, so just like the table above, we're going to have a column for machine X. We're going to have a column for machine Y, and then the difference between them, Y minus X. Okay. And let me just denote this. This is in month 6. Okay. All right, and so in month 6, we're going to buy a replacement, and so the replacement is going to cost $200. Okay, so we have minus 200. But in month 6, we can also salvage the first machine that we bought, right? And so we bought a machine X. It lasts us from months 1 through 6, and then we salvage it and we buy a new one. And so the salvage value for machine X is $50. Okay. And so it's not just going to be a minus 200, it's going to be a minus 200 plus 50. Okay. And so the net is minus 150. Okay. So the net extra cost that we obtained there is going to be minus 150. For machine Y, we don't have to replace it. Machine Y is going to take us all the way through the 12 months. And so if we go with machine Y, there's no additional cost in month 6. Okay. Okay, and so if we take the difference between these two, and so we do Y minus X, and so the replacement cost for Y in month 6 is going to be 0, and then we minus the negative 150 for machine X, and so what we get in the end is positive 150. Okay, and so to our net present worth equation, we're going to add positive 150 P over F I and 6. Okay. Okay, and so we're going to add this to the net present worth equation. Okay, so we have one more entry to do. Okay, and so our total net present worth equation is going to be minus 500 plus 25 P over A I and 12 plus 100 P over F I and 12 plus this extra 150 here. So 150 P over F I and 6. Okay. And to find the rate of return, we're going to set this equal to 0. Okay. All right, and so we've set up our net present worth equation. Everything here is accounted for, and so now we're just going to start plugging in some interest rates. And so remember, our MARR here is 10%, and so that's kind of what we're shooting for. Okay. All right, but because I wrote this problem and I know exactly what the answer is, I know that we're not going to be anywhere close to 10% actually. And so let's compute the present worth at I is equal to 1%. Okay. And so we plug all this in, we have a minus 500 plus 25 times 11.255 plus 100 times 0.887 plus 150 0.942. Okay, and then what we get from this is 11. Okay. Okay, so that's pretty close actually. And so, 11 is pretty close to 0. And so, we're in the right ballpark. And so let's see if we can kind of push it over the limit. And so let's check it at present worth is equal at I is equal to 1.5%. And so we have a minus 500 plus 25 times 10.908 plus 100 times 0.836 plus 150 times 0.914. We get a minus 6. Okay. Okay. And so what these calculations tell us is that the rate of return of the increment is somewhere between 1 and 1.5%. Okay. Okay. This is nowhere near the MAR. Okay, so and so in this case, I'm not even going to bother with the interpolation because I know it's going to be way far off. Okay. And so since the incremental rate of return is way less than the MARR, this tells us we should go with the cheaper option. And so the cheaper option in this case is machine X. Okay. Yeah.
So the outbound component, why did we choose a P over conversion?
Yeah, that's a good question. And so we chose P over F because that replacement cost is only going to occur once. And so basically, you machine X is going to die at month 6, and then you just apply a replacement just that one. All right. So a question I always get asked with these problems is, how do you know where to start, right? And so, a lot of rate of return problems involve you kind of choosing an interest rate and then just kind of guessing and checking, right? And so for all these examples, I knew where to start looking because I already knew the answer. But if you're doing these kind of on your own, how do you know what interest rate do you start checking with? Well, if you're doing the homework problems, and you guys have seen already on the homework problems, I give you the answer, and so you kind of know where to start checking already. But on an exam, if I were to give a problem to you like this, or if you're doing a calculation like this in reality, for the exam, I'll tell you kind of where to start looking. For in reality, a lot of times you kind of get a good sense of where it is, just kind of based on the field that you're in and based on kind of typical interest rates that you're used to working with. So, different industries have different interest rates that they're kind of used to, and then you just kind of start looking in that neighborhood. Okay. And so it's very rare that you're just going to do a very just random shot in the dark. And so you usually have some good idea of where you're going to start. Okay. All right. Any final questions? Okay. All right. So that's all we got time for. So thank you everyone for coming today. Remember, homework 3 due Tuesday, and then midterm exam next Thursday. So if you have any questions about anything, don't be afraid to let me know. Then I'm always here to answer your questions. But if not, have a great weekend. Take care of yourselves, and I will see you guys next Tuesday. Yeah.
Last time we were solving for the uniform, it was 5 years 5 to 9.
Yeah.
Could you do it where you do like
I could do that.
instead of 5 to 9, you start with like 0 to 9, 0 to 4.
Yeah, there's lots of creative
We
ways.
got a flashcard too.
You'll see me do this a lot. Actually, look the homework 2. Like there's one problem I think where I gave you like uniform series for like 2 years, and then it increases to that, it increases to that.
Oh,
And so what I did was I assumed that there was a single uniform series that goes all the way through at this level right here.
uh-huh.
And then I just added just whatever the increment. was. So there's, and so there's lots of different ways. you can-
Okay.
Yeah. Thank you. Mhm.
Even though this example, we just assume, or since we know we didn't have to.
Yeah.
We do that.
Oh, yeah, you can do that too. It's never gonna be this far off, and so I'm gonna give you cases where it's a lot closer, where
Yeah.
you guys should infer fully. But if it's this far off, then you can just say that it's so far off, and just say that you know exactly what to think.
But let's say like it was like in between like 9 and 8 range, you know, that's still not gonna be greater than something. So
Yes, in those cases, you're still gonna know, but for some of those cases, I still want you to go through the practical. infer fully. Yeah, because that's still of good importance. Too.
thank you.
Yeah. Mhm. Right, any final questions from Zoom? All right, I'll see you guys next week.